Hello and great to have you with us. In this session we want to talk about the topic of material science enabler for smart and digital industry products. You might think that it's all about rubber at Continental anyway, and in fact rubber continues to play an extremely important role at Continental. But it's far from the only material the company deals with. Today we will talk about the role that material expertise actually plays in a technology-driven company like Continental and what new opportunities it opens up for digital innovations as well. Before I welcome our guest, let me add an important note. We all were tested negative for COVID in the morning, so all of us are safe. But now let's give a warm welcome to Dr. Jens Högermeier. Hi Jens.
Pleasure being here.
Great to have you here. Jens, you are head of the Advanced Technology Development Department at Continental and you're working in material science. It's a new department. How was it founded?
Well, as you can tell already from the name Advanced Technology, Continental is a rubber company with 150 years, very proud this year, of DNA in rubber. But we noticed over the last few years that technology, of course, doesn't stop with rubber. So we needed to have an organization that really puts the comprehensive material expertise in the focus of this. So Advanced Technology Development, the team and me, we are working on solutions that go way beyond the normal rubber. We are working on enabling our strategy towards smart and digital products by expanding from rubber to thermoplastics and other material science. So that's what we then have as the comprehensive material expertise.
Yeah, you just mentioned comprehensive materials expertise. Why is a change towards that so important?
Well, as I've used two words already, smart and digital. If you would like to enable your products that you have in your product portfolio to be capable of being smart, being able to transfer data, to broadcast data, you need to integrate these digital components. But for that, you might often need a different material basis. You can't just take your rubber and glue a sensor on it. It's not that easy. So you need to go way beyond that. You need to understand how to integrate it. And that often brings you to the point where you say, okay, rubber might not necessarily be the only way of doing this.
For a better understanding, maybe you can give us an example.
Yeah, I actually can give you two examples. Let me give you one that is more on our automotive side, but I think everybody sees at the moment that we are changing from combustion engines to battery electrical vehicles in the market. It's a very strong trend. If you open the bonnet of your car, you classically see a lot of tubings and everything. They are used to transport liquids. They are used to transport exhaust gases and things like that. But their main purpose, and they were usually made from rubber, is this transportation and being there and being durable. If we are now looking at a battery electrical vehicle, one of the most important points is to have the thermal management of the battery operating well. So you need to integrate a broad range of tubings that control the temperature of the battery. And at the same time, you need to know at the points where and what temperature you have. So you need to integrate sensors into your tubing. This is a good example where you have a complex product that includes sensorics that is not made from rubber in this case any longer, but is made smart by the integration of sensors. But of course, we're talking about industry. And Industry 4.0, of course, is one of the key points. So let me give you an industry example. And I've brought actually a picture with me. Here you can see one of our brewery hoses. These, of course, have to ensure that if you think about a brewery operation, you have big compartments where you have a specific temperature and it's a specific time. You need to extract the material so we all get our beloved beer. And in this situation, of course, you first of all need to have the right connections. So from one area with a certain temperature, it needs to be pumped to another. At the same time, we're talking food industry in this case. So you need to ensure that your hoses are maintained properly, that the ones that have to be cleaned are in the right spot, the ones that have been cleaned are in the right spot, and the ones that you want to use immediately are also in the right spot. And for this, you can make your hose smart. If you put an RFID in your hose and you connect, and now you have a connection between your reactor and your hose, You can at any point of time see if your connections are right, if the right hose is in the right way. So this allows, for example, also for predictive maintenance and things like that. It really makes that next step of smartness in your Industry 4.0.
Let's talk about engineered thermoplastics, what that is all about.
Well, engineered thermoplastics, it has already the word plastics in it, and a lot of people think when they hear thermoplastics, think of the classical water bottle in the ocean. In our case, that's not the situation. And I actually have another picture with me. Here you can see our tech center, our brand new tech center in Hamburg. And here we are able to produce tubings and hoses in a way that we have different formulations that can then be extruded to different types of hoses with very different applications. And if we are now talking about engineered thermoplastics, we're really talking about high-tech materials. So we're talking about materials that allow specific functions. And to give you a range of these functions, one of the things that is very important is conductivity. And there's different types of conductivity. You can have heat conductivity. So for cooling, you want to get the heat out of the system. But you can also have conductivity that you want to have the cool and transport the temperature to your battery, for example, that I mentioned. Another important thing where you can conduct something is electricity. So you might have something that needs to conduct electricity, or you might also need a material, a engineered thermoplastic, that is non-conductive, that insulates. That's the whole conductive area. Another very important point, of course, is that when we're talking about hoses, for example, that you have a barrier function. That you have, for example, very specific materials that you want to transport in your hose, where you need to shield the environment from it. Very dangerous chemicals, for example. Another option we had before with the brewery hose, where you have something that is a food good. So you want to ensure that your barrier to the environment is very safe and doesn't bring anything from the environment into your food material. And then, of course, also you have materials like gases and others that need that barrier to simply stay inside the hose.
You just talked about the functions. Where do you use these functionalities?
It's actually a really good question, because I just mentioned the barrier function. And one of the big topics that, of course, we see in the media and in popular science a lot at the moment is the talk about hydrogen and fuel cells. For that, you need to transport and you need to refuel with hydrogen. Hydrogen is a notoriously small molecule. It is the smallest one that we actually have to deal with as a gas. And it pretty much can get through everything. So if you imagine now that you have in the future hydrogen-driven cars, but more likely, first of all, we will see hydrogen-driven trucks and maybe even ships one day, you need to refuel these. You need to ensure that the hydrogen is transported from the refueling station cleanly into the car. And for that, you might need in the future refueling hoses, for example, that have that barrier function that I mentioned before, that really put the hydrogen where it's supposed to go, into the engine and not into the environment through the hose.
But does that mean Continental won't be working with rubber anymore in the future?
No, it really doesn't. We have those 150 years of DNA, and we have that extreme expertise. And there's always the place for rubber as the right material. In the end, it comes down to having the right mix for the right application. Some things might be better being used with thermoplastics. Some things really, like, let's say, a conveyor belt, for example, that really has to be very durable and that has to last over a long time in adverse weather conditions and other things. Here, rubber is for sure still the material of choice for us. We would never give up that expertise, because it takes many years of expertise to really get those formulations right. It's a little bit like when you have companies like Coca-Cola. They'll never tell you what's in it, but the recipes make really up for the know-how. And this is something where we are, of course, on the rubber side as well. And it's very important for us. But again, it's about the mix. You have products where the thermoplastics are the right choice. You have some where the rubber is the right choice. Thermoplastics definitely have the advantage of being a little bit more easier to make sustainable.
In the future, what do you think? Will thermoplastics dominate, or will there be another solution?
There for sure will be other solutions that might come our way. But in the end, thermoplastics, as I said before, have one great advantage, and that's the sustainability option of it compared to rubber. Let me tell you a little bit more about that, because it doesn't sound like it, right?
Yeah, absolutely. Because on the one hand, you have plastics, and on the other hand, you have sustainability. They are in conflict, aren't they?
They are. It absolutely, and something where we like to provoke with this a little bit, because we want to have that discussion going as well. In the end, the sustainability discussion, when it comes to keywords like plastics, is of course very heated, very emotionally charged in the public. And there's a lot of perception in the public that anything that's fossil fueled, of course, it can't be right. And yes, that's right in the first step. However, we need to understand a little bit more on a detailed level, on a scientific level, what sustainability in material science really means. When we talk about a sustainable material, we have 4 different points that we always look at. Firstly, it's the origin of the material. This is actually the non-science part mostly. It's important to ensure that the material is free of human rights conflicts and other things. So we need to make sure that we understand where our material comes from. The second point is the feedstock. This is now where it gets technical. You need to ensure that it's either recycled, or it's from a regrowable source, for example, or it is a classic fossil material. So this is where we need to see what's the feedstock. The third point is, what is the influence on our production landscape? As a company that produces classical things with a lot of fossil material, we need to see, if I change, does that change my production environment? For the better or for the worse? It could be that I change something in the production, and out of nowhere, although I'm using a good sustainable material, that's called a good material, my carbon footprint in production goes up. So I use more energy. That's not necessarily beneficial. So we have to always balance that. And the fourth point is, what happens to the product? Because if I use, for example, a material that is sustainable, but my product durability goes down, what our customer actually wants, then it might not be the right way. And he has to throw the product away earlier. On the other hand, if throwing away means that this product, for example, is compostable, then it would be a great thing to renew your product over and over again. So as you see, the simple answer to it's fossil fuel, it must be bad, on a scientific level for us, in terms of material expertise, is a very complex question to answer. And I want to give you an even more detailed example for this, because I said before, rubber is better, thermoplastics is better than rubber. Why is that? Let's think about when you're baking a cake. You have flour, eggs, butter, milk maybe, and you mix that together and you bake it. And then a chemical reaction is happening, and this is changing the structure and the molecules in it. The same thing happens when you're using rubber. When you're using rubber, you mix your rubber, and then you go through the process of vulcanization. This is a chemical process where something a little bit similar happens to what happens in the oven, in your cake. But if I tell you now to get the flour back from the cake, it's impossible, or the egg, or the butter. It's simply not possible. The same thing with rubber, it's not easily recyclable. But if you think of chocolate, for example, if you make something of chocolate in your kitchen and you don't want to eat it afterwards, you melt it down and you can make something else out of this chocolate. This is similar with thermoplastics. We can recycle them easier, and we can melt them down again and use them easier compared to rubber. Second aspect in this that we also shouldn't forget, and this goes back to what I said is the third point, the production impact. When you're producing in rubber, you have to vulcanize, an extremely energy-consuming process. Thermoplastics don't get vulcanized. They just are melted and brought into form by extrusion and some things. So again, you see with this whole example that it's a very complex question that we have to answer, which for us as material science is extremely exciting. And really sustainability causes a lot of questions, of course. For me as a scientist, it's extremely exciting because we get to do so many new things, and we have so many new technical questions, especially on the material side, that need to be answered. It's very exciting.
Yeah, I see that. But thermoplastics aren't the end of material science, or what do you think?
I really don't think so. If you think back of what I talked about in the beginning, that we want smart products, smart industry solutions, it would be, of course, ideal if the whole product itself becomes smart. At the moment, you integrate sensors, you integrate electronics. But if we think for one moment that the material itself can be made smart, then out of nowhere your whole product becomes a sensor. So for example, if you think about that the whole material that the hose is made out of that we produce, then you can sense at every single point of the way. You have immediately information about temperature, pressure, whatever you need in your production from your actual material. So one of the dreams for us as material scientists, of course, is to create even more smarter material in this way in an industry environment. There is some smart materials, everybody knows these, but if we can go that next step, then it definitely doesn't end at thermoplastics and rubber. It's that next step where we can make materials smart and with that follow our vision towards being digitally driven and becoming a smart and sustainable solution provider.
Wow, Jens, thank you so much. Great insight, and I'm sure we will see a lot of more great innovations coming from Continental. So thanks for being our guest today.
Thank you very much. It's been an absolute pleasure.
Cool. Ladies and gentlemen, I hope you have enjoyed our session as well. Continental would be pleased to get in touch with you on this topic. Simply use our general contact address in our HMI 2021 Continental dashboard. Till then, be safe and have a great day. Bye.